All right, welcome kids to our last video lesson for Unit 5 today, or Unit 8, I'm sorry. We are going to be talking today about solving systems of inequalities. It's going to be very similar to Section 1, but it's also going to combine some things we learned in Unit 7 about solving and graphing inequalities. All right, so it's very similar to what we've been doing up to this point, doing systems of equations. Again, a system is anything that consists of two or more. All right, so we looked at systems of equations, so there were two or more equations involving x and y. And here we're looking at a system of inequalities. So it's the same idea, same principle as before, but instead of seeing x plus or x minus y equals 7, we are seeing an inequality. Same thing, 2x plus y is less than 8. We are not seeing the equal sign, but the big difference here is that we are now dealing with inequalities. The whole property, the whole principle, however, is not anything different than what we talked about up to this point. Okay? So what we're going to be doing now is we're going to be trying to find a solution to this system of inequalities. Now, if you think about what we've done up to this point, a solution to an equation, you had only one solution. Remember, what we had to find was we had to find a value of x and y such that those values of x and y, when we plugged them back into our system of equations, would end up making both equations true. So the x and y satisfy both equations. Well, it's going to be the same idea here with inequalities. However, with inequalities, when you see things like less than or greater than, or less than or equal to or greater than equal to, these are not going to have one solution, but they're going to have many solutions. I won't necessarily say infinitely many, but they're definitely going to have many solutions. And our goal, again, is we're going to represent these solutions by certain regions on a graph. Today, what we're going to focus on is simply understanding these solutions by graphing these inequalities. But let's take a look at some examples first. Again, what does it mean if I want to know if something is a solution? So let's say I give you the point of 3, negative 5. Again, 3 is x and y is negative 5. How do I know if this is a solution to the system of inequalities? Well, what we did before with equalities is we'd have to take this value of x and y and plug them into both inequalities. So I have, again, my inequality is x minus y is greater than 7. So if I plug these in, that's going to say 3 minus negative 5, is that greater than 7? Okay, so if you apply my rules of negatives, that's going to give me 8 is greater than 7. Does that work out? Yes, it does. Now, what about the other inequality? So I have 2x, so 2 times 3 plus y, and y again is negative 5. Is that going to be less than 8? Okay, so 2 times 3 is 6. 6 plus negative 5, is that going to be less than 8? Well, 6 plus negative 5 is 1. Is 1 less than 8? Check, please. So is this a solution? Yes, it is. Okay, so just like it would be for equations, it has to satisfy both inequalities. Same principle. All right, now let's check the next point. What about 5, negative 2? So let's see if this one works. Again, I'm going to say x is 5, y is negative 2. I'm going to plug these into both my inequalities. So I'm going to have 5 minus negative 2. Is that greater than 7? So I'm going to add 5 and 2, apply my rules of negatives, and I'm going to get 7. Is 7 greater than 7? Well, no, 7 is equal to 7, so that doesn't work out. So right away, is this a solution? No. Okay, if it doesn't satisfy one, it doesn't satisfy all. That means it's not a system or a solution to the system. So same principle here. The only difference is we're looking at an inequality. All right, so what we're going to focus on in this lesson primarily is looking at graphing linear inequalities. So this is going to take you back to section 7.5. So you might want to go back and revisit that, either watch the lesson, take a look at your notes. But remember, we're going to have to follow these principles of graphing linear inequalities. So I put up here this slide. This is just a snapshot of one of the videos we made for 7.5. Remember, these are the rules that you need to follow when graphing linear inequalities. Remember, you're going to graph it just like you would a line. You're going to look for, make sure it's in slope-intercept form, y equals mx plus b. The only difference is we're not going to have the equal sign. Okay, then you're going to make sure that depending on the less than, greater than, or less than and equal to, or greater than and equal to, you're either going to have a dashed line or you're going to have a solid line to represent those things being on the solution. And then remember, you're going to shade. Okay, so wherever the line is, you're either going to shade above it or below the line. Okay, so go back and take a look at those rules in order to understand how to graph these linear inequalities. So let's take a look at our first example. We want to solve the system of inequalities by graphing. So the two inequalities I have, don't want to call them equations, is 3x plus 2y is less than or equal to 6, and x is less than 2. So what I want to do is graph both of these. First rule says I'm going to take this and see if we're in slope-intercept form. Let's graph this first one. I have 3x plus 2y is less than or equal to 6. Is this in y or slope-intercept form? Y equals mx plus b. And no, it is not. So that means I have to make sure I get it. How do I do that? Is by solving for y. So first thing I'm going to do is subtract 3x from both sides. So I'm going to have 2y is less than or equal to 6 minus 3x. Then divide by 2, and I'm going to divide everything over here by 2. It's going to give me y is less than or equal to 6 divided by 2 is 3. Then I'm going to leave this as 3 over 2x minus 3 over 2x, because that's going to represent my slope. So again, graphing this, here's my y-intercept, here's my slope. So that's b and that's m. So I'm going to start at 3. I'll do this one in purple. So I'm going to start at plus 3, apply my slope. I'm going to go down 3, so down 1, 2, 3, right 2 to this point. Do it one more time to there. Okay, so I plotted a couple points. Now I need to determine, is it going to be a solid or dashed line? The inequality is less than or equal to, so this is going to be a solid line connecting these points. All right, and then lastly, I'm going to shade either above or below. How do I know the difference? Well, again, I'm going to look at the inequality. It says less than, so remember less than, I'm going to shade below this line. Okay, so that means a solution for at least this inequality is going to fit in this region here. Now, notice we have another inequality. I'll do this one in red here. We have the inequality x is less than 2. Okay, so I want you to think, how are we going to graph this one? Because I want to represent the solution from a graph. X is less than 2 is very similar to an equation or a graph of x equals 2. So you got to think back, what does this look like when x is 2? Well, x is 2 is right here, this point. Okay, well, how do I represent the line x equals 2? Well, remember that this line would be a vertical line, straight up and down at x is 2. Okay, now notice we have the inequality x is only less than 2. So when I draw this, I'm going to draw this line as a dashed line. Okay, because it's not equal to. And I want you to really think about this. Well, it says x is less than 2. So how would I represent this? Because it's kind of a rule breaker, because I'm not above or below, but I'm left or right. Well, think, if this is a value of 2, that's a value of 3, that's a value of negative 1, or sorry, not negative 1, positive 1. Which one is less than 2? And it'd be the value to the left. So that means I'm going to shade in every region left of this line, or the entire region left of this line. Okay, now with this, remember that with an equals, we looked at the point where they're intersected. So this point right here. Now with the inequalities, we are looking at the region of the graph where these two things overlap. And notice that the two regions overlap in this spot right here. Oops, let me get my highlighter tool. They overlap right here. Okay, we kind of have two boundaries formed by the line, and everything in this region is overlapped by both the red and the purple, so I'm going to shade this in green. What this means is that every point in this portion of the graph represents our solution. Okay? So this region is now our solution, and it's not an individual point. If I asked you to pick a point that would be a solution, well, all you have to do is pick a point in this region, and heck, I could pick a point right there at negative 1, negative 1. That point right there would be a solution to both inequalities. Okay, so it's the same kind of principle as section 1 where we're graphing, but now we're actually applying what we learned in Unit 7, and we're looking at regions of graphs, multiple solutions that would solve the system of inequalities. Excellent, let's try one more, but now, just a little test. I got 3 of them here for you, 3 inequalities. Let's see if we can graph these. First one, I have y is greater than or equal to negative 1. Think back to the last problem. We have x equals 2. That was a vertical line here. Well, y is greater than or equal to negative 1. Negative 1 is here. Okay. And then it has to be, you think, y, there's no x variable, so instead of a horizontal line, we're going to have vertical line, we're going to have a horizontal line left and right. Meaning this line is going to go left and right. And notice I drew it as a solid line because of the equals, and then we want to represent the region greater than. So let's see if I can highlight in black. Good, it's a little gray. That's perfect. So I'm going to shade this entire region above that line. Okay. Next one I have, let's do this in red. I have x is greater than -2. Well, -2, whoopsie daisies, let me undo that. -2 is right here for my x. Okay, then I want to look at my line. This is not going to be a horizontal line, but a vertical line at x equals -2. But since it's just greater than, not equal to, it's going to be a dashed line at x equals negative, or as x at -2, I should say. And I want to represent anything greater than, so greater than is going to be anything to the right of this line. So I'm going to shade there. Now you can kind of see already, see the region here where both of these overlap. That means our solution may be in here, but we do have one more to graph. Okay, so I'll do this one in green. I have x plus 2y is less than or equal to 4. Again, we need this in slope-intercept form, just ignoring the equals. So I'm going to take, first I have x plus 2y is less than or equal to 4. I'm going to take and subtract x from both sides. That's going to give me 2y is less than or equal to 4 minus x. Divide by 2. And I'm going to divide everything over here by 2. And that's going to be y is less than or equal to 4 divided by 2 is 2. Remember, what's the number in front of negative x? It's -1. So I'm going to have minus 1 over 2x. That's going to tell me this is my y-intercept of 2. And -1 over 2 is my slope. That's going to be down 1, right 2. So I'll graph this. I'm going to go up 2 on my y-axis. Be careful now with my shading. Then I'm going to go down 1, right 2 to apply my slope. Down 1, right 2. Down 1, right 2. Heck, I'll go up 1, left 2 as well. And lastly, is it going to be a solid or dashed line? You should see here, because of the equals to, we're going to have a solid line that goes through all of these points. All right. And then we want to represent all the values less than. So I'm going to shade below the graph. Now, the tough thing is you need to find, if we have 3 inequalities, our solution is going to be the region where all 3 overlap. Can you view this? I know there's a lot of colors on here, but can we see the region where they all overlap? And yes, that would be this region right here. The red, the black, and the green all overlap here. That's why I said there's not going to be infinitely many solutions, but that means that any point within this shaded region is going to represent a solution. So this right here, whoopsies, let me undo that. Whoa, didn't mean to do that now. Ay, hold on, let me reshade these. Ay, everything's falling apart. So we had that, then the blue we had in here. And again, what I was trying to do, here we go. This represents our solution. And if I were to pick any point, say the origin 0, 0, that would be one of many points in that region of space that would represent a solution to the system of inequalities. All right, so again, the whole purpose here is we're representing a solution as a shaded region. So notice here we have 3 inequalities. These ones are given to you. You can see the line. You got the solid line, the 2 dashed lines here, and you see that there's shaded region. Anything here represents a solution. So now let's take a look at some of these points. First one, is a point of 0, -1 a part of our solution? So what we had, 2 things we have to pay attention to here is we have to pay attention to the shaded region. So that's the first thing we need to pay attention to. The second thing, which is kind of tricky to understand, is we have to pay attention to the dashed line versus the solid line. Remember, the difference between these 2 things is that if it's a solid line, any point that's on the line is a part of the solution, whereas a dashed line, the reason why we're using a dashed line is that any point on this line is not a part of the solution. So we have to look at these 2 things. So 0, -1, first of all, I'm going to move left and right 0, then I'm going to go down 1, so my point's right there. So notice how this falls on the dashed line. Does it fall in the shaded region? No, it does not. So is this a solution? No, it is not. Okay, needs to fall within the shaded region, and you also need to pay attention to the lines. So let's take a look at the next one, 2, -2. 2, -2, I would go right 2, So right 2, down 2, that would be right in here. So is 2, negative 2 a solution? Yes, it is. Notice how it is inside the region that is shaded, so we know automatically that's a solution. Next one, 2, negative 5, so I'm going to go right 2 again, go down 5, and I'm going to go to right here. So notice this one is not necessarily in the region, but it is on the dashed line. So if it's in the region, or sorry, kind of on the boundary of the region on the dashed line, does this count as a solution? And here's the purpose of the dashed line. Again, this is dashed because we are saying any point that is on this line is not a part of the solution. So this one, our answer is no. If it's not in the region, it must be on a solid line. Okay, so the next one, if I go 1, 2, 3 to the right, 3, 0, is that one a solution? Solution. Is this one a solution? Well, notice it's not in the shaded region, but it is on the line, and notice that this is a solid line, not a dashed line. That we are saying, because it's a solid line, any point that's on the line represents a solution. So, yes, this is a solution. One of the key things here you guys have to understand is with these inequalities, what counts as a solution or not a solution. All right, last example here. Let's see if you guys can figure this out. I want you guys to pause the video here, and I want you to graph these two inequalities, and I want you to shade in the region and find where your solutions would lie. So give the video a pause. Here you go. All right, let's take a look at what you got. So I paused on the solutions here. Notice I had the blue line and the green line here. The blue line I did, up 1 for my y-intercept, did my slope of up 1, right 2, up 1, right 2. Same thing with the green, I did down 2 for a y-intercept, but the slope was the same, up 1, right 2. Notice the slope is the same. First of all, do the two lines intersect? No, this is what we learned last section, our special cases. If the lines don't intersect, that means they're parallel. Does that necessarily mean with inequalities? Remember, with equalities, there would be no solution because the two lines would never intersect. But with inequalities, we have to pay attention to the shaded region, because if a point lies in the overlapping regions, then it would be a solution. However, in this one, notice how when you shade the regions, I shaded above here for greater than. This one was less than, so I shaded below. Notice the two regions don't overlap. So what does that mean? Remember, we want to find the overlapping regions for a solution, but they don't overlap, so that simply tells us no solution. Okay? So very similar to last section, however, we have to pay attention to the overlapping regions. All right, so this one again is combining section 5 from last unit as well as a little bit of stuff from all these other sections. So make sure if you have any questions, jot those things down. Good luck on the practice problems and good luck on the mastery, and then you guys got your test. See you in class. Peace out, my friends.